Hello, guys. Can you guys hear me right now?
Yes, we can hear you.
Hey, that's cool. Let's just need to change something with my camera setting. Hey, hi everyone. I'm sorry, I dropped out of the connection when I was trying to debug my video feed. Okay. Yeah, so just confirming you guys can hear me all right and you could see my webcam as well.
No webcam yet, but we can hear you.
Okay. Let me just try that again. Okay, it says here others should be able to see me right now. Okay, so okay, thanks James. Hey Nika, could you try speaking up a bit?
Hi, can you hear me well now?
Yep, yep, can hear
Okay.
you. Cool. Okay, there we go. Yeah, I guess we better get started. Thanks for everyone who's here today. I see today we have 58 participants and counting. Okay, so yeah, we're excited to talk to you about getting job ready with AI, but with more focus on engineering. Okay, okay. Yeah, just a bit of uh, things here. If you want to disable sounds or pop-ups, okay, you have to go to the settings there and yeah, go to notification settings and untick all the boxes there. Okay. Yeah, and yeah, before we start, just some common questions and FAQs. So a copy of the slides and video will be given to everyone since you've registered the to this webinar. So you will receive a copy of the PDF and a link to the video in the next business days via email. So if you haven't received it by then, you could just check your junk and email folder. Also, a certificate of attendance will be given. So that's going to be a free digital certificate for live attendees. So at the end of this webinar, we will have a link and a QR code, and you just have to answer a short form survey at the end of the session. Once you complete that, we'll send you your certificate probably in the next 4 business days. Okay. Yeah, before we start with the actual content, just a little bit about EIT. So EIT is one of the only institutes in the world specializing in engineering. So we deliver professional certificates and diplomas, advanced diplomas, undergraduate and graduate certificates, also bachelor's and master degrees, and also a doctorate in engineering. So also a good difference with EIT with other institutions is our programs are actually designed by industry experts. So this ensures that you graduate with cutting edge skills that are valued by employers worldwide. So our program content is always updated rapidly because in engineering and in tech, it's always a rapid change in technology, and there's always industry developments happening. So here we go. Hey, can everyone still hear me right now?
Yes, we can.
Okay, cool. So another thing with EITs, we offer world-class Australia accredited education. So our vocational programs and higher education degrees are registered and accredited by Australian government. So our programs are also recognized under three international engineering accords. So these are the degrees and programs are recognized worldwide. Our lecturers are also highly experienced and subject matter specialists with applied knowledge, so not just theoretical knowledge. So yeah, the technologies employed in EIT, both online and on campus, enable us to source our lecturers from a large pool of global expertise. So, and yeah, in terms of our delivery model, we deliver our programs using a unique delivery approach that makes use of live and interactive webinars. And yeah, as I said earlier, an international pool of expert lecturers. We also have dedicated learning support officers and state-of-the-art hands-on workshops, remote labs, and also simulation software. So these are just a few of the awards that EITs achieved throughout the years. So number one in quality of educational experience for undergraduate engineering programs in Australia. Number two, quality of educational experience for postgrad engineering programs in Australia. Number two in student support undergraduate and postgraduate engineering programs in Australia. And number three, teaching quality for undergraduate and postgraduate engineering programs in Australia. Yep. Uh, yeah, um, so before we start, I'll just talk a little bit about me. So my name is Kasey Martin, and I work as a special projects lead for EIT. So I've been in the tech industry for already 10 years, and 4 of those years have been in geospatial engineering, where where we applied LiDAR, if you're familiar, a light detection and ranging to create high resolution flood maps for certain areas here in the Philippines. And yeah, after that, I've been working for 5 years with EIT, wherein I've been solving problems in NLP, computer vision, data analysis, cloud computing, and cybersecurity. So another personal note about me is I'm a lifelong learner and I like to tinker with all things tech and engineering. Okay. Now, yeah, let's start with the webinar, which is getting job ready with AI. In in my part of the presentation, so in our agenda, first just gonna have a brief introduction to AI and engineering. Then we're going to talk about preparing for the future with AI and engineering. What kind of skills do engineers need in the AI age? Some talk about ethics and responsibilities that we have to have in AI, and then careers in AI and engineering. And then lastly, key takeaways. So this is just going to be like a um, short presentation to prime you up for the main presentation, which will be given by my colleague Nikka uh, in a few minutes after. Okay. So, introduction to AI in engineering. So, in the chat box, can anyone tell me what AI is? What AI is? Anyone just tell me what does AI mean? And um, just a brief definition. There are no minus points for Googling it and pasting it here. Thanks, Adrian. Okay, artificial intelligence. Oh, volume. Okay, I'll try to speak up more. Thanks, uh, Mzu Kisi. Sorry if I'm saying your name wrong. Okay, so Adrian says artificial intelligence. And what is the, can anyone tell me what artificial intelligence means? Thanks, Gabriel. So artificial intelligence. Okay. Now, okay, thanks, Mark. So Mark says that it refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. Okay, Mark, thank you for that definition, and that definition is spot on. And Marian says deep learning through the use of machine learning and simulation of human intelligence. Adrian, making machines that can think like humans. Nice. I think everyone's got the gist of what AI is, and this is good. This means that we are aware of AI. So nice. Okay, Benji, decide based on algorithms and robotics and automation. Yes, also part of AI care. Replacing people with machines. Oh, that's a very scary one. Come on, yeah, maybe maybe replacing people where it's dangerous to put people in. That would be more appropriate. Okay, so thanks everyone for joining in on defining AI. So yeah, AI basically involves the development of algorithms or programs that enable machines to actually simulate human intelligence. Now, can anyone tell me the most basic form what engineering means, or what is it about? What is engineering about, and what's the definition of engineering? Okay, so Alphonsus says to build. Okay, that's correct. So with engineering we build. So what do we use to build? So okay, Angela. Okay, Angela says it is engineering is the application of theories and ideas, basically the tangible part of science. Yes, I like that word, tangible. Maths or science, build and design using maths and science, fabrication of structures and materials needed. Applied science. There we go. Yep, looks like everyone's got engineering right as well. So with engineering, what we actually do is, oh, all the research that comes into sciences, we actually apply that to actually solve problems. Um, yes, yes, James, there is an attendance here, so you will need to scan a QR code later and fill out a form to get your certificate. Okay. Um, And then going back, yeah, engineering, basically the application of science and mathematics to solve problems. So for decades, engineers have been using science and mathematics to actually solve human problems. Now with the advancements of with the advancements of AI, what actually happens is AI becomes the perfect complement to engineering because it enhances efficiency, accuracy, and innovation across various engineering domains. So, for example, in automation, AI streamlines repetitive tasks. So, in this, some of you may be saying, that sounds a little bit like what programmers do with programs. Yes, so that's also so yes, you could achieve automations with programming. You know, wherein there you have to have a programmer or an engineer that actually outlines the steps in the algorithm to actually automate the task. But you could also have AI give AI a goal, and then the AI will over time learn how to actually achieve that goal. And sometimes the automations that AI actually finds is actually better than algorithms that humans design. And that's one of the things why it's the AI is good for automation. Now, another good thing about AI is it can be used to increase efficiency. So, by increasing efficiency, that means that it reduces human effort and error. Okay, so with if, for example, with our previous example in automation, right? Um, when when you actually for humans, like for example, if humans are in the assembly line, humans can get tired sometimes and they can make mistakes. But if you actually have a robot or an AI do something in the assembly line, the robot does not get tired. Maybe the oil will have the oil within the robot will actually cost it to if it's old enough, the oil, maybe the robot will fail at that time, but usually it's more efficient than than a human. Do you guys agree with that? Do you think it's more efficient to use robots in assembly lines than humans? Yes. Yes. The other day I tried doing some manual work, and I do agree because doing manual work made my hands really sore. So that's a good thing that AI is there to help us with that. And another thing is AI can be applied in engineering is in complex problem solving. Okay, so an AI can actually enhance an engineer's problem solving abilities by processing vast data sets. So who among you here just sees like a 1 MB CSV file and you just open it and then you look at the data? Can you understand in a few seconds what that data means? If you open an Excel spreadsheet or a CSV and then you just look at the data, can you immediately decipher what it means or retain the information in your head? Wow. Hey, Rajiv, you have to teach me your your technique on how to actually analyze data by eye. But yeah, for most human beings, it's actually hard to decipher just um, yeah, it's actually hard to decipher a large CSV. Imagine gigabytes of data being that needs to be analyzed. So computers and AI could actually see patterns that humans can't because they have vast amount of computing power that's available to them now, given the recent advancements. So, um, given that AI could see patterns that we previously could not, these actually enhances an engineer's problem-solving capability. Yes, yeah, Rajiv, just tell me your secret, okay, on how to analyze spreadsheets better by eye. Okay, and yeah, it also with AI. Yeah, maybe the first. Rajiv, are you an AI? You have to tell us. Maybe we have to apply the Turing test to you. Um, yeah, so another thing in AI that can help with engineering is in innovation and creativity. So since AI makes us work faster through automation efficiency and helps us understand more complex problems, an engineer's mind is actually more free to go and explore more novel design possibilities with AI-driven tools. So because because with AI we actually need less brain power, or at least we could offload the heavy lifting and just become concentrate on the creative side of engineering, and that can help us. Okay. So given that AI is ever progressing, okay, in this year, I think everyone knows ChatGPT, right? Is there anyone here who has not heard of ChatGPT yet? Okay, a bit of silence there. Maybe a lot of can you guys still hear me? Okay. Yeah. I guess everyone's silent because they don't want to acknowledge ChatGPT. That's okay. But yeah, the thing is, as AI continues to, thanks everyone. Okay, as AI continues to drive innovation and shape the future of engineering, okay, with emerging technologies, things like applying AI in augmented reality, IoT, and even virtual assistants, it actually unlocks new possibilities, and it has the capacity to actually revolutionize almost any industry. And all with all that positive things, you also have challenges and risks. And I think that that's why everyone is here right now in this webinar is because we're concerned with one of the risks, which is job displacement. Okay, it is where AI and automation may have the potential to disrupt traditional job roles, and yeah, this could lead to job displacement in certain industries. So with that, we need to actually address the impact of AI on employment and develop necessary strategies for retaining and upskilling. Okay. So how do we keep ourselves relevant? There's another challenge with AI is there become, or at least with any type of technology, is you also have ethical considerations. So as AI becomes more integrated into any and all engineering processes, there are a lot of ethical considerations that arise, and we'll talk about them in a later slide. Yes, yes. The first seminar was also launched in the Philippines. Yes. Yeah. So let's talk about this. So how do we address this job displacement risk? Okay. So first thing I would want to say is in order to still be relevant in an AI age, engineers should first be domain experts in their fields. Okay, so if you're a domain expert, that means that yeah, you know you know the ins and outs of your current engineering field, and yeah, and you're basically an engineer in your own field. Okay, and with the addition to that, engineers now also need to have a bit of data literacy. So can anyone tell me what's the difference between data and information? So what's the difference between data and information? So data and information. So what is data and what is information, guys? Okay. Um, a lot of silence, but I'll say the difference between data and okay, there we go. Adrian, thank you for that. So data is raw. Okay, so data is raw and okay, some kind of okay, there we go. A lot of answers. Information is the set of data. Okay, that's good. Data are raw inputs while information are collection of processed data, and then data is unprocessed information, collection of facts. Okay, looks like everyone knows data versus information. So data, basically, as Adrian said, it's raw. It's raw, like raw inputs. This could be like sensor data, like values, numbers, strings, and then information is what you make out of data. Okay, information is the understanding of the collected data into something that's useful to us. So engineers need to be able to understand and turn data into information. So what engineers should be able to do in an AI age is they must know how to extract insights from data using AI tools. And yeah, another one that engineers actually need in the AI age is programming proficiency. Okay, thanks, Jerson. So interpreted data is information. That's good. Samuel, maybe you could try rejoining and checking your browser. permissions to hear audio. Yeah, that's going back. Another thing that engineers need in an AI age is programming proficiency. So you guys basically need coding skills because this is essential for developing and implementing AI algorithms. Um, and another good thing with being good with programming, another thing that's good with being good with programming, this is in terms of things like generative AI, is if you're good or if you know how to program, you can articulate your thoughts better to turn them into more useful prompts if you're using something like ChatGPT or a GPT related chatbot to actually do some work for you. So if you're good at programming, your mind's already hardwired to actually be good at logic. And yeah, programming AI tools. Programming is also good for programming more AI tools that can be applied for engineering. And another skill, which is this is more of a soft skill, you need to be good at adaptability. Okay, so engineers, I remember this one. There was one person here earlier who said that yeah, engineers will replace humans. I think a lot of people are scared. To be honest, I was scared too at the beginning of the year when I first saw ChatGPT. The thing is, we shouldn't be scared. Engineers should actually embrace AI as a tool for continuous learning and improvement and improved productivity. Okay, so don't be scared that AI will take your job. You have to adapt and use it as a tool. There's this quote from Seneca that I love. The quote is, "We suffer more in our imagination than in reality." Okay, so getting scared of AI instead of trying to use it and trying to understand how you can harness AI is actually detrimental to us. So what we need to do is we need to adapt to it, we need to accept it, and learn how to use it effectively so that we may be better engineers. Here's another quote that I like. If it loads. There we go. From Bill Gates, he says, as computing power gets cheaper, GPT's ability to express ideas will increasingly be like having a white collar worker available to help you with various tasks. So essentially, AI models like GPT will become increasingly versatile and capable of assisting in a wide range of tasks. This actually aligns with the broader idea that AI can augment human capabilities and be a valuable resource in various fields such as data analysis, decision making, um, among other stuff. So essentially, imagine this: even if you start working for an engineering firm and you're actually just a junior engineer, even if you're a junior engineer, you could have in the future, or it's actually close here in reality now, you could have a personal assistant already as a junior engineer that can actually help you get through the day quicker. Okay. And yeah, oh, GPT, Chat GPT. I actually forgot what GPT meant, but I think Nika will answer you, Kimonye, in on her part later. Okay, so GPT is a type, but forgot what it means. But yeah, GPT is a type of language model. Okay, that actually replies to you, and it appears to be as it looks like the answers it gives out seem to be correct. Okay, seem to be correct. There we go. Thanks, Nika. So GPT stands for Generative Pre-trained Transformer. Okay, so yeah, it looks AI looks pretty good now that we're not a bit not too scared of it. Hey, there's a robot. Um, yeah, essentially everyone's gonna have their own personal assistants, and some of you may be thinking that you could just have AI do everything for you while you still keep your jobs. Well, I have this other quote for you. It's a Russian proverb. I am not fluent in Russian, but I will try to say it. Doverye no proverye. So anyone familiar with this and want to spoil what it means over the chat? So what does doverye no proverye mean in Russia? Um, not trust but verify. Ooh, that's good. Thanks, Mark. So essentially, what this means, thank you, Mark, that is absolutely correct. Trust but verify, and verify is in bold. So this actually recognizes the potential benefits of AI while emphasizing the need for ongoing scrutiny. So, scrutiny of the outputs of AI is very important. So, there has to be transparency and ethical considerations to ensure that AI systems operate in a trustworthy and responsible manner. Yeah, this approach is essential for building and maintaining public confidence in AI technologies. So essentially, what this means is you can't just have AI, just do something like Jarvis, build an Iron Man suit for me, and then trust that the Iron Man suit is not gonna crush your body. That's why I said earlier that an essential skill for engineers to be still relevant is to be actually domain experts. So as domain experts, AI could generate outputs faster than humans, but it's up to us to actually verify if whatever output that AI actually has put forth is actually right or valid or for confirms within a certain threshold of truth. Okay, so we can't really rely on AI to do everything for us, or at least not yet. But I do hope that AI always relies on us um, to be the domain experts. Okay. Next, let's talk about ethics. So there's a few ethical things here: fairness and non-discrimination, accountability and transparency, and yeah, regulatory compliance. Let's talk on each one. So for fairness and non-discrimination, engineers must ensure that AI systems are actually designed and implemented in a fair and non-discriminatory manner. The thing is, like for something like chat gpt or large language models, right, or any other type of data, there will always be some sort of bias in the data. So for example, if a majority of something that you're analyzing was made by let's say if you're analyzing sentences or product reviews, and then a majority of the reviews came from male reviewers, then obviously that's male biased, and you need to address that in your training data. You have to collect more data and just normalize the data just to be fair with other other stakeholders that might be using your product. Okay. And another thing is accountability and transparency. So engineers should prioritize accountability and transparency by providing explanations for uh, providing explanations on how AI has made those automated decisions for us, and making the decision making process understandable and auditable. So we have to be accountable. Okay, so you can't just have AI in the black box and just trust AI. Whatever the AI says is right. You need to understand why the output of the AI was that. And yeah, regulatory compliance. So without regulation, it would be anarchy. Okay, so we need to ensure that AI systems are developed and deployed in a responsible and ethical manner. Okay, in accordance with regulations created by governments and regulatory boards around the world. Because without regulation, we might actually end up with something like Terminator. Okay, so that's very important. Yeah, now let's talk about careers. So what careers can you actually do with AI? Think, yeah, the first one, really common, data scientists. So the thing is, engineering firms right now have lots of engineers and data, but they actually lack data scientists to properly understand the data. So if you're a domain expert and you also have a data scientist background, a lot of engineering firms are going to want to be looking for you and wanting to employ you because yeah, domain expert and data scientist combo, it's very crucial. Another one is an AI engineer. Okay, so uh, to be always relevant, you could be the one. that actually you could be a domain expert AI engineer with that will help propel further use cases in domain specific problems. Okay, so the thing is, AI engineers, uh, usually the AI engineers, they're computer scientists, right? And then they could only they could only think of so many applications for engineering because they are confined by being good at computer science. But if you are a domain expert and then you can apply it to being an AI engineer, you could think of more use cases for AI technologies. Another one is robotics engineer. Okay, so you could design AI robots to do jobs that humans can't do or are environmentally dangerous for our fragile human bodies. So places where, yeah, it's too difficult for us, that's where we need to be replaced, essentially. And yeah, if you're on the more business side of things, what you could do is you could become an AI product manager. So you could solve specific business problems with the help of AI products. Okay. So yeah, and that would be the that would be the end for my part. Okay, and let's just end with a bit of takeaway. And the takeaway here is because of the way AI is progressing on the positive side, we think that AI is probably here to stay. And if AI is probably here to stay, you need to learn to use AI responsibly in your own engineering domain. And in order to be in order to be job ready, you also need to keep yourself relevant. So how do you keep yourself relevant? It's really lifelong learning and understanding AI and understanding how to apply AI in your specific domain. Okay. So yeah, thanks everyone for listening. And now we will be tuning in to my colleague, Nika.
Thanks, Casey, for that great and insightful presentation. Can everyone hear me well? Hello? Oh, okay, great. Okay, so hi everyone. I am Nikka Boquio, an AI developer here at EIT. So I have around 5 years of experience in artificial intelligence and ML or machine learning, with both smaller and larger projects, mostly on deep learning on fields such as natural language processing or NLP and computer vision. I also have 3 years of experience as university researcher where I took on larger ML projects and had the opportunity to contribute to AI literature. So I was also able to present my papers on machine learning at conferences, and I also have been published. Here at EIT, I am an AI developer where I apply my knowledge to several AI projects, and I also do some data analysis and visualization. And also, I am an enthusiastic learner, curious about the intricacies and endless possibilities of AI and machine learning. So let's begin with my presentation. So for this part of the presentation, we're going a bit more technical and practical. Now, of course, to use AI for engineering, we of course need to understand the basics of AI. And then we'll also be discussing the AI engineering toolkit, wherein I'll touch on some techniques and tools that you can use for AI in engineering. Then we'll move on to practical AI applications of uh, AI in various engineering fields. And then we'll be discussing the future of AI in engineering. And then I'll be ending with some tips and recommendations. Okay, now to start off, again, what is artificial intelligence? I believe we already discussed that earlier, but uh, more formally, AI is the broad science of mimicking human abilities. So basically, AI aims to create machines that mimic human intelligence. And as we can probably see, it's very much a dynamic and rapidly evolving field. Now, there are three main types of AI. First, we have narrow AI. So this is AI that's specifically programmed to do a single task. So for example, virtual assistants such as Siri Alexa. We also have recommendations, such as the one used by Netflix or Amazon, or even image recognition. Now, the next two types are currently not in existence yet. First is general AI. So this is the type of AI that can use intellectual activities equivalent to human beings. So they are as smart as human beings. So basically, they can understand, learn, and adapt, and even do some problem solving. Now, the next type is super intelligent AI. So this is the type of AI that exceeds human intelligence and basically have extraordinary problem solving capabilities. Now, this is usually what we see in science fiction, futuristic predictions, and so on. So here we have different concepts on which AI's basic principles revolve around. So first is learning from experience. So there are a lot of AI systems which learn from data and then they try to improve their performance over time based on the experience they have with that data. And this is achieved through machine learning. Next, we have reasoning and problem solving. So here, AI systems use algorithms to analyze and draw conclusions from data using logic. A third is perception. So here, basically, AI systems try to understand and interpret the world around them. So an example of this is computer vision, where it can process and analyze visual data in order to understand the world around them. Next is natural language understanding. So here AI systems are able to interact in human language and communicate with users. A good example is, of course, anyone, like what we have discussed earlier. Okay, some silence, but yeah, as we have discussed earlier, ChatGPT, because it's able to interact in human language and communicate with users. And finally, we have knowledge representation. So here, AI systems store and retrieve knowledge to answer questions, make decisions, and even predict outcomes. Now, if you take a look at all these principles, you could see that it's very data dependent, and which is true. AI is very heavily dependent on data, and it's really important that we make information out of that data for to use in several applications. So, yeah, next. Now, as we can see, AI is one of the fastest growing technologies, but let's take a look at some actual statistics. So first, 92% of companies are seeing returns on their AI investments. So I'd say that's a pretty large number. So that's 92%. Next, 80% of CEOs intend to incorporate AI technologies within 2 years. So obviously, it's important that we also adapt to that. Next, we have statistics related to productivity. First, 81% of employees believe AI enhances their overall performance at work. And 64% of businesses expect AI to increase productivity. Now, as we can see here, AI has been very promising and it's very much expected that AI is here to stay. So, of course, we need to adapt to that. Now, when it comes to the AI job market, uh, it is said that AI is expected to destroy more than 85 million jobs by 2025. So that's a lot of jobs. But uh, actually, in when it comes to automation, it has and will continue to take over jobs that humans have done historically. So, just like in the industrial era. So, with automation, it's kind of expected, but it's also expected that AI will create more than 97 million new jobs by 2025. So, that's a lot of uh, new jobs. But what this tells us is there will be a shift, a transition. So it's really important that we manage the transition carefully so that we can minimize the negative impacts on us humans, on us workers. And finally, the percentage of jobs requiring AI skills has increased since 2014. So AI was actually introduced way back in the 1950s, but uh, in the last decade, AI is becoming more prominent and it's growing so fast. So there are definitely a lot more new opportunities, and engineers who understand and can work with AI will be in high demand in the coming years. Now, when it comes to the engineering job market, here are just some of the ways that AI is impacting the engineering job market. So first, as discussed earlier, we have automation of routine or repetitive tasks so as to increase the efficiency and productivity, for example, in manufacturing. Next, of course, we have data analysis. We're currently in the big data era, and we have AI algorithms right now that can process and analyze them much more quickly and more accurately than humans. Now, this would be useful in a lot of engineering fields like civil engineering, where we can use AI to analyze structural integrity and even predict potential failures. Next, we have design and testing. So, for example, in mechanical and electrical engineering, we can use AI to simulate and test the design of tools before we even build them. Okay? And next, we have predictive maintenance. So we can actually use AI to predict when a machine is likely to fail so that we can, of course, maintain them before it actually fails. One field in which this is really helpful is in aerospace engineering. And finally, we have innovation. Now, obviously, as AI evolves, there will be more innovation and transformation. And one of the ways it's used is in biomedical engineering, where it's used to develop new medical devices and treatments. It's also used in civil engineering, where it's used to create smart cities. So definitely, AI has been very impactful currently and will continue to do so in the coming years. Now, do I think that AI is a threat to engineers? No, I do not. Uh, Actually, I think that it will just enhance the capabilities of engineers by making them more productive and give them time and room for more creativity and innovation to develop. Now, with this quote by Dr. Richard Alfield, AI won't replace engineers. Engineers using AI will. So what I think engineers should do is prepare to adapt to the latest tools available to them, as we should really expect to see changes in every area of engineering. So one of the ways that we can adapt is develop skills in designing and maintaining AI systems. Now let's talk about AI and some of its subfields. Now, as I mentioned, AI is the broader concept of machines that can mimic human intelligence, but machine learning here, or ML, it's quite popular recently. This is a subset of AI that trains a machine how to learn from data and make decisions or predictions based on that data without programming them to do so. Now, this is gaining so much popularity lately and it's driving much of the current advancement in the AI field. Now, a subset of both of these concepts is deep learning or DL. So here it uses deep artificial neural networks to allow them to automatically learn a hierarchy of data representations. So these techniques are really powerful and usually so much better than traditional machine learning methods, especially when it comes to data. Now, if you're wondering what neural networks mean, so they're actually called as such because they are similar to the way we learn. So they're similar to biological neural networks in our brain. So as we get input from the world around us, as we get stimuli, we have these neurons in our brain that process this data and adapt our learnings and knowledge from them to be able to do tasks like predict what this object is or whatnot. So hopefully that gives you clarity on these terms, which are often used interchangeably. Okay. Now, to distinguish traditional machine learning and deep learning even more, we have this figure over here. So we have the top part in machine learning. It could take an input. So say we have an image here containing pixels. The first step would be to do some feature extraction. So what are features? These are actually characteristics or properties of the data that can help distinguish. So, for example, the color of an object, the texture, the shape, and so on. Basically, what helps us to determine or classify whether it's a car or not a car. So, after extraction, it goes on to the actual machine learning method. So, here we just have a shallow neural network with neurons and then the connections between the neurons. So the task would be to classify whether it's a car or not a car. Now, when it comes to deep learning, the feature extraction, which is usually done manually and it's quite a meticulous process, it's actually already done uh, automatically with deep neural networks because it can automatically extract them and then it can even capture higher level features that would help with the task. So usually, as we go deeper with the layers, we can capture more meaningful patterns in the data set. However, it does require a lot of data for it to work well. Okay, next. So next we have here the AI engineering toolkit. Now, to use AI for engineering, we need to have basic understanding of some of the techniques and tools here. So for the techniques, we have mathematics and statistics. Since AI and ML are heavily based on those, so it's quite helpful to understand concepts like calculus, linear algebra, statistics, and so on. And next, of course, we have programming and data structures and algorithms. So, of course, to be able to write efficient code, we need to understand data structures such as arrays and stacks, and so on. Next, of course, we're working a lot with data, so it's important that we also understand or know how to pre-process them. So this includes cleaning the data, handling missing data, and data transformation, since real-world data is usually messy and incomplete, so that's necessary. And of course, we need to be able to learn some machine learning and deep learning techniques, and I'll go over some of them later. So specifically for deep learning, familiarization with neural networks are really crucial. Next, for tools, I'll be giving examples of these later, but we of course need to know to use some programming languages. For example, Python is one of the most popular for AI, and of course, ML and DL frameworks and libraries. We have big data technologies since usually we can't process large data sets using traditional data processing software since we're dealing with very large data sets. And of course, we need some familiarization with cloud computing as well, since deep learning algorithms are computationally intensive, and you would need very, very powerful GPUs. And of course, we need to know some visualization tools because we need to gain insights from the data and visualize them. Okay, so let's start with uh, machine learning process. So typically the process here is first data acquisition. So we of course need to gather the data and prepare them to use as training data. So this data could be uh, like numbers, photos, or text. So we could get those from sensors or reports and so on. So usually, the more data, the better the program, since of course we're going to be learning from that data. Next would be data preprocessing. So this includes filtering out unwanted data like noise. We of course want to do some data transformation, handle missing data, so that they are all ready for the next step, which is feature extraction. So here, obviously, we want to obtain features that would help identify or discriminate the data. Now, like I said, with deep learning, this is automatically done. But if you're just using a traditional machine learning model, you also need to do this. Now, finally, we have training and evaluation. So what we do is we choose a machine learning model to use, feed it the data, and then train the model on that data so that it can find patterns or make predictions or do classification. And usually we can even do things like change the parameters so that the model would be better and produce more accurate results. Now, of course, we also need to evaluate the performance of the model. Of course, we wouldn't want a model that is inaccurate. So we also do some evaluation, use some metrics like accuracy, precision, and so on. Okay, now let's talk about the different machine learning methods. So we have here supervised learning. So this is where we train the machine to learn with data, on data with labels. So we label them like if this is a car or not car, we give that to the model. Now the opposite of that is unsupervised learning, wherein we look for patterns in unlabeled data. But we also have a combination of both, which is semi-supervised learning, which uses both labeled and unlabeled data for training. And a different one is reinforcement learning. So this actually uses trial and error to see which actions would yield the greatest rewards. So we train them to uh, to accomplish the ultimate goal. So, but we establish a reward system for this one. Okay, now let's go over each one uh, one by one. So first we have supervised learning. So like I said, we're working with labeled data. So for here we have shapes. Now we would feed the data itself and then we would give the labels of whether it's a rectangle, a circle, triangle, or hexagon. We then feed it to the machine for it to use the machine learning model that we have used. We also usually uh, separate the test data for the machine learning to make its predictions on. So of course, we wouldn't want the machine learning model to use data that it has already seen. So that wouldn't be very practical. So that's basically the process in supervised learning. And here are some examples in classification and regressions. We have support vector machines, naive Bayes algorithm, nearest neighbor classifier, linear regression, support vector regression, decision trees, and of course, neural networks. Now with unsupervised learning, like I said, we're working with unlabeled data since uh, labeling data is actually very expensive and time consuming. So it's not always the case that we have labels for so much data. So uh, here the idea would be to look for patterns that we can use to group the different data into subsets. So really just find some structure within so that we can group them together according to their similar characteristics. Uh, yeah, so some examples of techniques are the k-means clustering, hierarchical clustering. We can even use neural networks, Gaussian mixture, and so on. So one way that we can use this in engineering is, for example, fault detection. Now, say in a factory, we can analyze sensor data and perform clustering. Now, in normal operating conditions, the sensor data would fall into specific clusters. But if the machine behaves abnormally, the sensor data would actually deviate from the clusters. So say we have a data point that is out of the clusters. And this would help us detect faults with the machine. So that's how we can use uh, unsupervised learning in engineering. Next, we have self-supervised learning. So I do actually want to to discuss this a bit. This is a subset of unsupervised learning. So this is very important because it has driven a lot of important advancements in AI that we see today. So self-supervised learning is still under unsupervised learning, so it learns from unlabeled data, but it actually tries to automatically generate the labels by solving a pretext task. So this predefined pretext task is what we give to the network to solve. So an example would be math language modeling. So we randomly mask some words and then task the network to predict that. Or even it could predict if a sentence is the subsequent sentence of another sentence. So what this does is it uh, by doing this, the model can learn a lot of features and knowledge, which we can then transfer to the downstream task. So then we can just use, say, normal supervised learning here. So the downstream tasks could be the tasks that we're actually interested in. So, for example, question answering, sentiment analysis, text classification, and so on. Now, one application of this is autonomous driving systems. So say we have a car that drives along the road, and of course it would have some sensors that captures a sequence of images. Now, given that sequence of images, the task would be to predict what comes next. So say a pedestrian would come in front of the car, and naturally in the same frame, the pedestrian would still be in that frame, right? So by predicting what comes next in the sequence, it would know what action to do. So that's one application. Next, we have semi-supervised learning. So like I said, this is partially supervised and partially unsupervised. So usually we just have a smaller amount of labeled data to guide the classification. And then we also have the unlabeled data. So one use case of this is just use the small amount of data to train the machine learning model. We then feed the unlabeled data to predict the labels of that unlabeled data. So we call this the pseudo labels. Then maybe we can even use all of this data. So both the pseudo labeled data set and the small amount of data set for our new model that we can use for our new data. So usually this is used when we do not have a lot of labeled data. And one example is in predictive maintenance. So we can just use a small set of data that we know uh, are set to produce certain fault conditions. And then we do not have to label all of that data in order to predict when a machine is likely to fail. Okay. Next, we have reinforcement learning. So here we just program the algorithm with a distinct goal and a set of rules for accomplishing that goal so that it could learn through positive or negative reinforcement. So we program the algorithm to seek positive rewards if it performs an action that is beneficial towards the ultimate goal. And we want it to avoid punishments when it performs an actions that gets it further away from the goal. So it has three main components. We have the agent, which would be the learner or the decision maker. We have the environment that the agent interacts with and the different actions that the agent can do. So typically this is used in robotics, also in gaming and navigation, and even reduction in energy consumptions. So say in robotic manipulation, if a robot is interacting with different objects in its environment, we can use reinforcement learning so that we can teach the robot to do certain tasks using just trial and error, and we don't have to program it to do this, to do that. So it learns by itself using the trial and error. So yeah, that's for the traditional machine learning methods. Next, we move on to deep learning methods. So like I said, it uses deep neural networks, basically neural networks that consist of more than three layers. So the idea here is by going deeper, we get more meaningful patterns in the data set. So an example here is we have an image with the different pixels. So say in the first layer, it could detect the edges in the data. In the second layer, it can now even detect the individual parts of the face. And maybe in the third layer, it could now detect the whole face, the structure of the different parts of the face and how it's shaped on the face. So that's for computer vision. But in when it comes to text, we could be able to detect some word features, going on to sentence features, and then to the whole document features, so that it could analyze the structure and yeah, just go deeper. But of course, like I mentioned, this needs a lot of data. Now, some examples of this are the following. So when it comes to supervised learning, we have convolutional neural networks, which are very popular in computer vision. We have multi-layer perception, recurrent neural networks. These are useful for handling sequential data. For unsupervised, we have GANs, or generative adversarial networks. You might have heard of this. Basically, from the word generative, it tries to generate data. So, say artificial images or videos or audio, like in deepfake. We have autoencoder and even RBN. For hybrid, we have hybrid deep neural networks and also transformers. Now, a while ago, I said the what do you call this? The meaning of GPT is generative pre-trained transformer, so it actually falls under this one. And transformers are actually the dominant model when it comes on. And transformers are actually the dominant model when it comes to NLP. So here we usually try to pre-train on a large text corpus and then try to fine-tune on a smaller data set. So this is what ChatGPT falls under. Now, in line with that, I do like to talk about the large language models like ChatGPT. So these models are models that assign probabilities to sequence of words. So take note of the term probabilities, which means that it is probabilistic and not deterministic, which is why ChatGPT has the tendency to spurt out inaccurate text because it actually produces the text that is most likely to follow rather than what is necessarily the most correct information. So yeah, we train it on a large amount of data and just have it try to learn a lot from that data so that we can then transfer to certain tasks like question answering, text classification, information retrieval, and so on. Now, for some examples, obviously for some closed source, we know Chat GPT, GPT-4, GPT-3, also Google's Bard. For open source, we have Falcon, GPT-TJ, Planty5, and so on. Now we also have domain-specific LLMs. So basically, they are trained on domain-specific data so that they're more tailored to the respected field. So for example, in finance, we have Finbert or Bloomberg GPT. For biomedical applications, we have Biomed LM or BioGPT JSL, and so on. Now, onto the different tools that we can use for AI in engineering. Of course, we have programming languages. Most popular ones are Python and R. So Python is very popular because it has a lot of libraries that makes it easy to deal with large set of data. And we can also use R. This is typically used in statistical analysis. Uh, of course, we also need to be familiar with some machine learning libraries. So for example, in Python, we have the scikit-learn, so basically a machine learning toolkit. We have NumPy for numerical computing. We also have Pandas for the organization and manipulation of data. Now, for deep learning frameworks, we have some popular ones like TensorFlow, Keras, PyTorch. PyTorch is really nice because it's really customizable. Basically, these frameworks would provide a high-level interface for the designing and the training of the models that you have. And of course, we need to familiarize ourselves with some data visualization tools like the Python's library, matplotlib, for plotting, of course. Also have Seaborn. For R, we have ggplot2, and we also have a popular tool called Tableau. Now, for cloud platforms, basically we can use these services to train and deploy models without worrying about the underlying infrastructure. So examples are AWS or Amazon, Google Cloud, Microsoft Azure, and so on. Another important one is AutoML tools. So we have Google's AutoML, H2O's driverless AI, Data Robot. So basically, these tools could automate a lot of the repetitive tasks in machine learning, like feature selection, model selection. So of course, we don't necessarily know what model would perform best in our data, and even hyperparameter tuning to improve the model. And we do also need to know some AI ethics tools, of course. So we have uh, IBM's AI Fairness 360, Interpret ML, and Audit AI, since it's really important to we also implement ethical AI, usually for fairness metrics, explainability tools, and to preserve the privacy. So really just try to familiarize yourself with these if you want to use AI for engineering and stay updated. So yeah. Now we move on to the different practical of applications of AI in various engineering fields. So we have here different fields like civil engineering. We can use AI to predict infrastructure lifespan, optimize construction schedules, and of course, leading to improved safety. For mechanical engineering, we can use it to optimize the design processes. Of course, automate the manufacturing and, like what I said, the predictive maintenance to predict equipment failures. For electrical engineering, we can use it to optimize power distribution, improve energy efficiency, and also predict equipment failures. For chemical engineering, we can use it to optimize chemical reactions, improve process controls, and even design new materials. Now, for environmental engineering, we can actually use AI to predict environmental changes, such as in the climate or pollution. We can use it to optimize waste management and help in the design of sustainable systems. And of course, for biomedical engineering, we can use it to detect images from medical images. It's actually being done quite a lot recently. It's a great assistance to the doctors. And yeah, we can also use it to design personalized treatments depending on the person's medical history and even predict disease progression. So yeah. Now I'm aware that some of these are higher level tasks, but we don't necessarily have to use AI for those. We can also use it to uh, for lower level tasks so that we could be freed up to perform higher value tasks. So we can use LLMs like ChatGPT to assist in tasks that involve a lot of text data so that we're more efficient and less prone to human error. So a lot of these tasks range in automating repetitive tasks, the analysis of complex data sets and reports. So yeah, so we could use it to analyze different reports and even generate reports, generate summaries of those reports, and even optimize the designs. What else? Help it uh, use it to help you draft technical documentations and specifications, give ideas or suggestions for different activities, interpret your test results, of course, data analysis. For biomedical engineering, you could use it to analyze medical literature and so on. So really, there's a lot of applications of AI, even in just lower level tasks, so that we could uh, be more freed up to do innovation and creative in engineering. Now we discussed the future of AI engineering. So obviously AI is uh, going at a rapid pace and it's expected to continue to do so. Now this will have a lot of implications for engineering. So here are just some potential advancements and their impacts. So first we have predictive analysis or advanced predictive analysis. So uh, we expect AI algorithms to become a lot more sophisticated when it comes to predicting outcomes based on the data. So obviously this could lead to improved efficiency and safety. And next we have, of course, enhanced automation. Now, over time, we expect AI to be able to automate much more complex tasks. Uh, we could see this as help increase in productivity and help reduce human error. Also improve decision making. So we expect AI to be better at making decisions, leading to more effective and efficient solutions. And finally, we have explainable AI. So especially with neural networks, AI is usually considered to be sort of a black box because we don't necessarily know the features or the factors that led it to give that certain prediction or analysis. But hopefully in the future, we're able to gain much more clarity on this decision-making process, on how the models make their decisions based on the data that they have. Okay. And finally, I just have here some tips and recommendations when you want to use AI for engineering. Now, the most important advice that I have is to just take a proactive approach to learning and development. So really just understand and learn. So understand the basics that I have mentioned, like mathematics, statistics, programming, and so on, and learn about AI. So machine learning, deep learning, robotics, and so on. And there are a lot of resources online that you can even use, like online courses, online webinars, tutorials, and so on. Now, the next tip I have is really important in my opinion. This is hands-on experience. Uh, yeah, just try to work on projects that really apply, uh, to really apply what you have learned. So this could just, you could just start from something simple. So say, just recognize the patterns and then move on to much more complex uh, projects. So I think this will also really help you um, understand AI, but also appreciate it better because you know how you actually made it. Yeah. Next, we have, of course, understand data. Since AI heavily relies on data, so you must know how to handle it, collect, clean, and analyze it, and of course, get information out of it or interpret the results so that you are able to make data-driven decisions. And of course, we have the familiarization of AI tools, like what I mentioned earlier, basically just to help you implement AI algorithms without having to build everything from scratch. And of course, understand and implement uh, understand the ethical implications of AI. So, like what Kasey mentioned, the bias in AI, privacy concerns, also the job impact, and so on. And another tip would be to specialize. So just have a good understanding of AI and just consider specializing in a specific area. So say computer vision, NLP. Yeah, basically this will allow you to deepen your knowledge and just become an expert in that area. And of course, we have here incorporate AI in your current role. So this could just be something small like automating repetitive tasks using uh, ChatGPT to help you analyze text or give you suggestions or yeah, just help you with smaller tasks even just to help you make data-driven decisions and so on. So this will not just improve your skills, but also demonstrate your ability to apply AI in a real world setting. And finally, of course, stay up to date because as you can see, AI is rapidly evolving. Just there are a lot of latest trends and advancements that we need to stay updated in. Uh, attend webinars, read a lot of research papers, Actually, did you know that last year alone there were 500,000 papers published on the topic of machine learning? So yeah, that's quite a lot, and I don't expect you to read all of that, but at least just pick out the most interesting or most relevant ones to be able to stay up to date. So yeah, there we have it. Now to end this part of the presentation, I'd like to read this quote by Mark Cuban. So artificial intelligence will be part of the home just like the light bulb. And the quicker we learn and adapt, the more we can shape our future. So yeah. So that's it, everyone. Thank you for listening and attending. So here we just have a slide containing a QR code to receive your uh, digital certificate of attendance. So just fill out the form and survey here. So also note that this form will close Sunday, October 15th, and no further request for certificates will be accepted after the form has closed. So I'll give you a bit of time to scan this QR code, and then we can move on to the question and answer portion. Okay, is everyone done with scanning the code? Okay, let's move on to the Q&A section. And if anyone has not yet scanned the QR code, we can go back to it later also. So, are there any questions, anyone?
Hey guys, any questions? Silence usually means yes, but I'm not sure in this instance if that's a yes.
Okay, there seems to be no questions.
Thanks, chat.
Right.
Thanks,
Thank you,
Kelvin.
Kelvin. Thank you, everyone. Really hope you learned a thing or two. So,
Thanks,
like
everyone.
we said, we'll be sending a copy of the slides and I believe the recording of the presentation as well. And also stay tuned for your digital certificates.
Thanks, everyone.
Thank you.
Also, yeah, if you have any questions that are um that won't be discussed here, you could just contact us via uh the via the yeah the email links here. So email is eit@eit.edu.au. Send your queries there. Thanks, everyone.
Okay, thank you, everyone.
Bye.